All right. Now let's do what we left last week, our last lecture. So for beam, we are now in a beam chapter. So our F equal to KD equation is what you see on your screen. So our F usually will have mass and force and moment. And then your K is this one, standard, right? And your D is your vertical displacement, V, and the angle of rotation. Okay, so this is for element. Okay, one element, you have one set of this equation. Then after that, you combine, right? And then recall how to label the ticket, the position ticket for all these numbers. All right, all this basically is follow the D notation. So for example, if you take this equation you see on the screen here, um, you can label your pencil by looking at the displacement D here. So this one is V1, rotation 1, V2, and rotation 2. And then same with this one. So when you park your number into a bigger global matrix, then you can park the number accordingly. Okay, and then for beam, the K standard already. So if you're being asked to solve a beam question, then for one element, individual element, you write K equal to something, this one. Okay, so this standard already. All right, now just recap. Last week we tried to explain using this example to explain. All right, so usually the step is also you can say solve fix already. So first step, every time you look at the beam problem, straight away you write what is the K, what is the stiffness matrix for element 1. So you look at the question, the problem itself, and then you break into point 1, 2, 3. Mean usually the problems or the question itself will give you numbers 1, 2, and 3. And then you will label element 1 and 2. You look at the length, you look at if any external moment or external forces, and so on. Then the next step in your answer, we expect you write the individual K matrix. So K equal to this standard, although all these will be different. So once you write the individual K, you continue by using your pencil and write the ticketing, the ticket number for all these column and row. So for example, for element 1 is 0.1 and 0.2. So you write V1, angle 1, V2, angle 2. Then by the side, you also use pencil to write V1, rotation 1, V2, rotation 2. Right? So make this one as your standard practice. Okay? Because after you write this one, and then you write for the second element, you do the same, only you change the notation. Superscript 1 means element 1, superscript 2 means element 2. You see the number here, the same, always same. The constant value also same. EI over L cube. Of course, you in the test or exam later on, you need to be careful on the EI value and the L value. Okay, and for element 2, same, use your pencil to write the ticket number on the top and the side. Okay, so for element 2, you have 0.2 and 0.3. So you write V2, rotation 2, or angle 2, rotation, vertical displacement V3, and angle number 3. Okay, so you write this one, and then after that, the next step is you combine these 2K. Before you combine, I want to stress that before you combine, you try to make sure this one and this one will be the same. Because normally in test, the L will be different. Okay, the L will be different in test. So this L will not be the same as this L. So when you combine these two into a big matrix K, make sure these two is the same. Means you factor them out until you get the same factor. Then you combine. Okay, and once you get these two, you combine into a big matrix. After you get the capital K, the big matrix, we did this one. All right. So for this example, you have 3 points. So you have V1, rotation 1, V2, rotation 2, V3, rotation 3. Okay, so basically you follow your displacement matrix here. Okay, so then you put in all the numbers in this one. So I think you are good. You are good in this superimpose process. Okay, the next step you write F equal to KD. Your F consists of force and moment. Your displacement consists of vertical displacement and angle rotation. The K is what you combine just now. Then you look at the boundary condition. Boundary condition means you look at what happened to point 1, what happened to all the points. Okay, what are the points? So if the point can move, then there is a displacement. If the point cannot move, then the displacement is 0. If the point cannot rotate, means there is rotation equal to 0. And all this. Then you solve for the unknown. Okay, you start after you have the boundary condition. You can use your ruler or pencil just to close the respective. If in this example, if the point 1 cannot move, V1 0, you just use your pencil to close the row and column like this red color line. All right, you close, and then you extract the remaining matrix into a simpler matrix. Then you solve for all the unknown. Because if for this example, you reduce 6 equations into 3 equations here. So 3 equations and 3 unknown. This is the unknown that you need to solve. So you solve for this unknown. All right. Okay, and then last lecture, I think we solved one example already. Today we're going to look at a new tutorial question. Okay. So let's look at this one. Let me check attendance. The Ashma still not here. All right. Okay, now if you look at the screen here, we have a beam structure. Okay, would be a beam structure. Just check. Sue, are you there, Sue?
Yes, sir.
So you look at the screen. How many points or how many nodes that you have in this question?
5.
5 nodes, Okay, correct. The next question I will ask Brian. Brian, how many elements do you think you can break from these 5 points? How many elements? Brian, are you there?
Yes, sir.
So you look at the screen. We have 5 points here. Number 1, 2, 3, 4. So what do you think? We can break this one into how many elements?
1, 2, 3. So we at 1 we have 2.
Mm-hmm.
3 we have 2.
Total, you have how many elements you can break? Brian, are you clear with the question? Do you understand the question?
Sir,
Yes. How many elements you can construct from this question? Just now Sue mentioned 5 points. 1, 2, 3, 4, 5. So how many elements you can build from this diagram?
okay. Wow.
One element have how many points, Brian?
2, sir.
2. Okay, so you have 5 points. So how many elements?
10.
Huh?
You say every element has 2 points, sir.
Yeah. So how many elements you can have from point 1 to point 5?
So 10.
10. How you get 10?
Oh, yeah. So at point 1 we have 2 elements. I'll cut.
Do you understand you have 5 points, right?
Yes.
First element. You have point 1 and point 2. First element. Then this is first element. Second element. Where is your second element?
Point 2 to point 3.
So how many elements you can have from this question?
Oh.
Your answer is what?
We can have a. Oh, God.
Do you understand the question? I'm asking you what is the total element you can have from this question. You can answer the red color diagram that I draw on the screen here. Why can't you answer the remaining question?
Okay, sir. For element 1.
How many? Do you understand the question? Do you understand what I'm asking you?
Yes, sir.
So how many elements you can have from point 1 to point 5?
Oh, okay. 4, sir.
Answer is what?
4.
4. Okay. So what is the third element? Third element connecting what? Which point?
It's connecting 3 to 4.
Okay. Then this is element 4. Total you have 4 elements. All right. Now the next question I will ask Chia. Chia, you there, right? Chia, are you there? Chia Wen Chung, are you there? Chia, are you there?
Yes, sir.
All right, Chia, you look at the diagram. What are the external forces you have? How many external forces?
2.
2. So what is the value of the external forces?
1,000 Newton.
All right. So you look at the diagram. Chia, this question also for you. What is the displacement you have at point 1 and point 5?
0.
0. So this is V1, rotation 1, both 0. Okay, so in exam, if you write V1, rotation 1, 0, this one give you 1 mark, this one give you 1 mark. If you write 0.5, 0.5 also same. Okay, 0.5 also same, V1, B5, rotation 5, or angle 5, also 0. This one also give you another 2 mark. Okay, these two give you 1 mark, 1 mark. So by writing this V1 rotation 1, V5 rotation 5 equals 0, you get 4 marks. Okay, now what about point 3, Jia? What is the displacement you have at point 3? What do you think? What is 0 for point 3? I mean in the displacement dimension. What can you write? There's one more point that you can score from point 3.
V is 0.
V is what?
0.
Okay.
V.
Yeah. V is 0. Yeah. Okay. Yeah. You can say that V cannot go down lah. Huh? But of course, if you look at the force here, the 2 force here is pressing down. So the motion that you can have at point 3 is going down. Okay, it's pressing down. Okay, so your V1, V3 will be 0. Okay, then there's a rotation angle there. So this is another point that you can have. So you can see from the on the screen here, basically you can score 5 points from the diagram alone. So these 5 points, don't miss it in the test or final exam. Okay, you write what is the boundary condition of this all these points. You look at the diagram and then you write whatever is 0, then you score some point for that. Okay. All right. Okay. Thanks, Chia. Okay. Now, any question?
Actually, so on point 3, it's able to move in the horizontal direction because there's a pole and
yeah. Again, when you study beam, do we look at horizontal?
oh no.
Do we look at horizontal? Don't confuse with other chapter. This chapter is very special. Since the beginning, you look at this diagram. Oh, this diagram, the very first diagram that we see. Do we see any horizontal movement? Do you see any horizontal movement? No, right? So for beam, just remind yourself, we only look at vertical and moment and rotation. Okay. Then you look back to the question itself, and then you try to look at the steps now. The step actually is quite standard. Once you understand the steps, like step 1 you do what, step 2 you do what, then you can score quite high for this chapter. Right now, you see the question asks us to determine the nodal displacement, rotation, global stiffness, global forces, element forces. This one is quite standard. Okay, for beam, if you follow the standard, the step 1, you do that until the last step, you will get the answer. Then you're given the boundary condition for point 1, point 3, and then the roller support. Okay, then vertical loads is given. There are two 10,000 Newton on point 2 and point 4. E given, I given, and the L also given. Okay, the L also given. All right. So step 1, you look at element 1 with the question I asked Brian just now. This is the element 1. Element 1 connecting point 1 and point 2. So you write the K, the small k for element. Small k equal to EI divided by L3, which is standard already. Okay. Then use your pencil to go ahead and write the parking ticket number for the K. For example, this one, the first one is V. Oh, maybe I use different color. For example, the first one is V1, rotation 1, V2, rotation 2. Same, V1, rotation 1, V2, rotation 2. Any question for the first element? Any question that you're not sure? Any of you? Any one of you not sure what is, why I label this one? Okay, once you've done the first element K, you follow the steps. You go for element 2. Element 2 connecting point 2 and point 3. You do the build the same. Okay, so for point 2, for element 2, you build the same, and then label the you just issue the parking ticket for all these row and column. Okay, so for example, I write the black color notation on the matrix itself. So you look at element 2 connecting point 2 and point 3. So you have V2 rotation 2, V3 rotation 3. Also the side here will be the same. Then element 3 will be the same, element 4 will be the same. Only the parking ticket is different. Parking ticket is different. You issue ticket for element 3. You can see the number inside here is the same, only but the meaning is different. The location of their parking number is different. So for element 3, you have V3, rotation 3, V4, rotation 4, or angle number 4. You do the same for element 4, but only the parking ticket is different. So V4, rotation 4, V5, angle 5, or rotation 5. Okay. Now, any question on these slides? Any question on all this formula or all the notation used on these slides? Any one of you have question? Okay, Ashmal is absent for today's class. All right. Any question?
No question.
Okay, good.
Not yet. Not yet.
All right, good. All right, now the next question I'm going to ask, what is the size if you combine all these 4 matrices into capital K? What do you think the size that you will have? If you combine all this number, what is the size?
5 times 5 matrix.
Correct. Brian, you understand or not? Why 5 times 5? Not 5 times 5. Chia, is it? Or Su? Just now.
I think it's 10. 10. 10.
It's 10 times 10.
Yes.
Very, very big. It's 10 times 10. Meaning if you issue parking ticket, you have V1 rotation 1 until V5 rotation 5. Meaning if you park the number, you have 10 rows and 10 columns. It's going to have lots of a very big matrix. You use your pencil, you label V1 rotation 1 until V5 rotation 5. Because each point have 2. So you have 10 times 10. Brian, do you understand why it's 10 times 10 matrix?
Yes, sir.
Okay, good. So I'm going to go to the next slides. So once you combine, you will get something like on the screen here. You can see the matrix that I combined. So it's going to be 10 times 10 matrix, K in the middle, and the EL divided by L3. This one, remember, when you combine, remember to carry forward this one. Okay, I've seen students always forget to bring this one in the answer. When they too excited, they build all these are correct already, But when they write F equal to KD equation, they forget to bring the EL divided by 3. Okay. But let me mute you. All right. So just remember this one. Then you write, after you combine the K, there's a marks for capital K. After you combine, K normally will cost you 4 to 5 marks if you manage to get the correct superimpose process. This capital K is going to cost you 4 to 5 marks in the answer. And after that, you write F equal to KD with the correct symbol, right? Curly, bracket, and curly. And then you expand F equal to KD like what you see on the screen here, the blue color matrix. So F, you have F1Y, M1, and so on until point number 5. For D, also same, from point 1 until point 5. After you build F equal to KD, all right, so you have to identify this slide is just to show you where do you get the element 1. So for example, I label this one for you just for your revision. Okay, so element 1 is in the red bracket, element 2 is in the green bracket, element 3 purple bracket, and so on. Okay, so this is a superimposed process. Okay, practice this one, because this one will help you to score 4 to 5 marks to build the K matrix, global K matrix. Right? Now, then after that, we will apply the boundary condition. After you build F equal to KD, we will apply the boundary condition. Now, this boundary condition is what I asked, I think, Chia just now. All right, what happened to point 1, and also ask Brian also on the point. What happened to point? So V1 0. So once the point is 0, means the displacement and the rotation is 0. You use a pencil or you rewrite the whole matrix again. Then you use a pencil or you use a ruler just to close the respective displacement that give you 0. For example, if point 1 is cannot move, then V1 0, rotation 0. So you close with, for example, on these slides, I close with the red color line. Okay, you close like that because you want to, because this is a very big matrix and we have 10 equations to solve. So if we want to reduce the equation, one of the strategy in mathematics is that we look for the boundary condition. Those at 0, we close it temporarily. It doesn't mean that the F and the moment there is 0. We just temporarily close, make the row and column inactivate. So V3 0, V5 0, 0.50. Okay, so once you close it, you will see that there's a remaining matrix there. Okay, I will highlight with yellow. So this one left out, this one left out, here, 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 here. So make sure what you are clear when you write this one. Make sure you use a new space so that you can read your matrix clearly. Okay. Usually this one will use up, I think, 25% of your A4 paper. Okay, it will use like half pages, but normally you will use a quarter of your A4 paper just to write this big matrix. Okay, so the remaining one, you just rewrite them, put them in the new matrix. Remember to carry forward. Don't go and change all these notation. Okay, when you move them into a new matrix, if you see F2Y, then write F2Y. Don't change them into something else. Yeah. Okay, then you will have the blue color matrix like what you see just now. I already highlight with the yellow color space just now. I draw in the yellow color. So you put the remaining open space here. Okay, I remember to put the, okay, you pull the two F equal to KD equation again, but the remaining one. So you put F2y, M2, M3, F4y, and M4. Remember to pull your EI divided by L. Oh, sorry, there's a L cube missing here, typo error. And the remaining one, for example, this one. So this one, 12 times 12, you get 24 and so on. Okay, the remaining one you put here, and this one and this one put here. Okay, any question for the information you see on the screen? Any question you want to ask me? No, okay. Then you get the remaining. So here you have 5 equations. So you solve 5 equations. So this 5 equation, the F component, you already have the value already. You just substitute the external, the F equal to KD, this F component, the F matrix here actually is the external forces. Is what you see from the question, external, right? This is the external, the one. So you are seeing 2 forces there, and there is no external twisting moment or moment there. So this one 0, this one 0, M4 also 0. So F2y, when you export them, remember the direction. This also one of the area where students have careless mistakes. If you look at the diagram, the force is going down, so it's negative. Because our reference axis, X and Y is going up, positive, but the force is going down. So remember on the force direction, negative. Okay, same with F4. Okay, same with this value. The rest is just copy. Now you have 5 equations, so you just solve for this equation. Okay, solve for this equation. All right. Now, as you can see from here, we can put rotation at point 2. You can see here, point 2, point 3, and point 4. We can put as 0 because they are symmetry in loading. Okay, this is something new for today. If they are symmetry, what I mean by symmetry? If you cut this object into half at point number 3, you see actually it's behaving the same behavior, and the loading also load at the same distance. Okay, because the length is the same, 10, 10, 10, 10. So element 1 also 10 meter, and so on. Same with the element 2, element 3, and 4. But if the length is not same, you cannot do this. If the length is not same, this only apply when the length is same. Length is same. The load is same. Load location, load location is same. Okay, in this case, you can see I draw a yellow line here. Okay, so in this example, you have 0. In normal case, if the L is not same, if the L is not 10, it's not 10, it's not 10, it's not 10, then you have to solve 5 equations, simultaneous equation. Okay.
Doesn't the material effect?
Yeah, and
But the material is the same.
Yeah, the material usually will be the same because it's the same beam. Usually will be the same. For beam, usually will be the same. All right. So normally this component will be the same for your info. Only you need to solve 5 equations here. So this tutorial question is simplified already because the length is the same and the location of the external force is almost the same. You can see the same. point 2 and point 4 actually is the same distance from the symmetry plane that I cut here. So we can use this one. Huh? So in exam, look at the diagram, but normally the length will not be the same. So you cannot use 0 anymore. You have to solve 5 equations. Okay. All right. Now remind me to teach you how to use an online calculator later on, because I think I haven't teach this class using the online calculator, solving matrix question. So in this case, you can close all these row and column. So it will reduce again, further reduce to 2 equations. Again, this one only apply for this tutorial question because all the distance is the same symmetry. In exam, be careful. Exam, this one do not apply. When during exam, the length is not same. So you cannot use this one. So it will not be 0. Just take note. Okay. So you solve for this one. Then you get what is V2, you get what is V4. Once you get the V2, V4, you already get the all the parameter in your D, right? You solve all this already. Then you back to the general global matrix F equal to KD times matrix here. You solve for the 10 missing information on the F component here. Okay, you solve for all the F and M. After you solve for the individual element. After you solve for this one, you solve for example, this one is element, small f is element. You write the first element. So when you write element, don't confuse, don't straight away use the global matrix. You have to go to the element matrix where the k value, small k, is equal to this one, not the one that you see over here. Okay. Then the D value you already found. So you solve for small f, small m in the matrix here. So you solve for another 4 equation. Okay. So yeah. So then the rest you can read from the slides here. Okay. So when you have a symmetry scenario, you can simplify your simulation or your analysis to the diagram below on your screen here. Okay, when you simplify, when you have a symmetry case, then you can simplify. If you don't have symmetry, then don't do this one. Okay, yeah. Okay, any questions so far? No, right? Any question? Okay. No, I want you to expose you to an online tool. So if you go to Moodle, right? There's one matrix calculator online there. You can use this one to help you. Okay, you click this one. It will take you to this portal, or you go to Google. You just type matrix calculator. Okay, matrix calculator. Click the first link. You will arrive at the same portal. Okay, all right. Now, how to use this matrix? Actually, it's quite direct, like what your calculator can tell you. So you have 2 matrices here, matrix A and the matrix B. And you have all the function that you can tell the website to calculate for you. For example, if you want to increase the matrix, let's say 6 times 6, you just press the plus button to increase the size. So same with matrix B. It must be the same size. All right. So after that, then you fill in. If you do not fill in, it will consider as 0. For example, I will put in 1, 1, 1, 1 here. Those space that you do not fill in, it will automatic fill as 0 for you. And let's say I put in 2, 3, 4. I just randomly pick a number. So if you do not fill in, then okay. All right. Now once you expand the size, you fill in the number according to your answer. And remember that if you need to multiply with something, which is your EI divided by L cube or L, so this is the number that you multiply. For example, if your EI divided by L is 10,000, then you just press this one. After you fill in the matrix, you press multiply. So you will get the first answer for your matrix. Okay. Then after that, you can do the multiplication. So remember, when you calculate, you can import this answer into back to matrix A. So for example, you look at this one, you want to calculate this one times this one. So remember to put this number back to matrix A. How you put this number back to this answer back to matrix A? Beside the screen here, you can insert in A or B. If you press insert A, you will put here. You press insert B, you'll put here. So go and press insert A, you put the answer back to matrix A. And then if you need to do transverse, or you need to do the transverse matrix for matrix A before you times matrix B. So what you do, you take matrix A here, you just press the find inverse. Press find inverse, it will calculate inverse matrix for you. Here you see 0 because you are fixing 3 decimal point there, but actually there's a number. So you put back to matrix A. So what you do, you just press insert A. You see, there's a number there. So matrix A is an inverse matrix times matrix B. So you want to get the product of inverse matrix times matrix B. What you press is just press multiplication. Press multiplication, you get the answer for the multiplication. This is the matrix that you need to get. Okay. Now after you press this one, maybe you don't need this one anymore. What you do is there's a broom there, or clean. Just press the clean, erase the number and expand again. So usually your D will be 1, 2, 3, 4, 5, 6. Let's say you have this 6 number in your answer. So you take the inverse times the matrix again, you'll get the answer for this one. So you can increase the number if you want. Okay, so you can put back into maybe matrix A. So you can see the number here. Okay, so I introduce you the matrix calculator. You can use this in your coming test or coming final exam. Okay, of course you need to copy the value in your answer. All right, you still need to give me the steps, the mathematics steps. For example, if you need to do inverse, then you have to write inverse in your answer. Then you give me the final answer. Any question on these online tools? Any question?
No.
No, Brian, you know how to get to here? Brian, are you there?
Yes, sir.
Do you know how to get this matrix calculator?
Yes.
All right, good. Chia, you okay? Sue, you okay? All right, good. So this is a very useful tool for you to save your time in the calculator, in the calculation, because this module I do not test your mathematics. I test your understanding using all the mathematics model. So only the careless mark is in the matrix. The only thing I test you in this module is the superimpose, whether you know how to park the number. The rest, I do not test you. I mean, I do not test you how to do the inverse matrix and so on. So that one is under advanced mathematics or calculus. I assume you understand already. So it's no point I you lose some marks for the inverse matrix and so on. So this is a very powerful tool that help you to solve some question. All right, if no question, I think I will stop here and then we go for a short break. Then after that, we will go for a few more examples. Then we conclude chapter 4. Okay. We go for maybe now is we go for 10 minutes breaks. We continue 9 a.m. Okay, we continue. All right, see you guys 9 a.m. We have a short break.
Okay, sir.